Beneath the waves off Okinawa, where the East China Sea stretches deep and blue, something rises from the darkness that shouldn't exist. Stone structures, sharp angles, flat surfaces meeting at right angles, arranged across the seafloor with deliberate geometry. The formations sit 25 meters down, massive and impossible, carved from the volcanic rock of an ancient plateau. Divers who descend into that space report the same sensation, a strange vertigo, a feeling that they're not exploring a natural wonder but excavating a ruin. A monument, perhaps. A city, maybe. Something that predates everything we thought we knew about human history. The site is called Yonaguni, named for the small Japanese island above it, and for the past 3 decades it has haunted archaeology with a simple, terrible question. What if we were wrong about when civilization began? What if the history books, the university lectures, the neat chronologies we've constructed are built on silence, on the absence of evidence that we've mistaken for evidence of absence? 15 years ago, a documentary crew descended into those waters and filmed what they saw. Structures too regular, too symmetrical, too obviously worked to dismiss as coincidence. The footage made headlines, sparked debates, ignited speculation that refused to die. But somewhere between the first dive and now, between wonder and scholarship, something happened. The evidence got quieter. The claims grew more cautious. The story transformed from a mystery into a footnote. Yet the stones remain. They wait beneath the waves, geometric, arranged, patient. And anyone who descends to see them faces the same choice the academic world has been struggling to avoid. Admit something doesn't fit the narrative or find a reason not to look. The tension between what is visible and what is officially acknowledged has become the defining characteristic of Yonaguni. Multiple surveys have documented the site with increasing precision over the years. High-resolution sonar imaging has mapped the underwater topography. Submersible footage has provided even closer views of the structures. Multiple independent diving expeditions have confirmed the basic observations. Yet with each new confirmation, the official response has grown more muted, more defensive, more insistent that natural explanations can account for everything observed. As if repetition could transform improbability into certainty, as if enough theoretical explanations could overcome the stubborn face, test presented by the stones themselves. Yonaguni's discovery wasn't a sudden revelation, but a slow realization that emerged gradually, the kind that happens when someone pays attention to something everyone else has already forgotten or never bothered to examine. In 1988, a Japanese diver named Kihachiro Arataki was exploring the waters near Yonaguni Island, looking for new diving spots to attract tourists and researchers to the region. The island's local economy had been struggling, and underwater tourism seemed like a promising direction for economic development. Arataki knew these waters well, had dived them countless times, understood their rhythms and dangers. But on this particular afternoon, something caught his eye that he'd never noticed before, or perhaps had never looked for. Beneath the murk of the current, stone formations emerged with a clarity that seemed impossible. He surfaced, gathered equipment, and descended again. What he documented would become the spark that ignited decades of controversy and confusion. The formations Aratake discovered were substantial. A massive stone platform, roughly 50 meters long and 100 meters wide at its base, rose from the seafloor like a stepped pyramid. The terraces were flat, meeting at angles so precise they seemed to defy the casual erosion of geological time. Stone blocks, some weighing many tons, fit together with joints so tight that a diving knife couldn't slide between them. On the eastern face, a curious spiral staircase carved directly into the stone descended downward into darkness. Near the southern edge, grooves ran parallel, straight, and deep, as though carved by something larger than hands, something with intention and force. The whole structure radiated intention. Not all of it was immediately obvious. Some formations blended so seamlessly with the natural rock, that it took repeated dives, multiple angles, careful photography to distinguish the work stone from the weathered basalt around it. But as Arataki and other divers began mapping the site, a pattern emerged. This wasn't a single structure, but a complex, a network of interconnected platforms, walls, and passages spread across several hundred square meters. There were what appeared to be roads aligned in straight lines. There were what might have been docks or harbors. There were terrace structures that could have served as residential spaces or ceremonial platforms. The complexity suggested planning, organization, purpose. Someone had organized this space deliberately. Someone had moved stone, shaped it, arranged it according to a design. Arataki's discovery made local news briefly, then national news, then international. By the early 1990s, diving organizations and researchers began to take serious interest. In 1997, a Japanese geology team descended with modern equipment and produced detailed maps and measurements. The formations were real. The precision was undeniable. The photographs were clear enough that even skeptics had to acknowledge something geometric was down there. This wasn't subjective interpretation or wishful thinking. This was stone, shaped, arranged, waiting. The mystery should have been obvious then, should have prompted rapid investigation, expeditions, the full machinery of archaeological inquiry. Instead, something else happened. The evidence seemed to disappear from public discourse, replaced by controversy about what it all meant, and more troublingly, whether it meant anything at all. When something doesn't fit the conventional understanding of history, academia has a well-worn response. Find an explanation that makes it fit. If that explanation seems improbable, make it more technical, more specific, more difficult to challenge without specialized knowledge. The conventional explanation for Yonaguni followed this pattern with surprising speed and remarkable consistency. The formations geologists and archaeologists began to argue were not artificial constructions at all. They were the result of natural geological processes, specifically a phenomenon called columnar jointing. When basalt cools, sometimes it contracts and cracks into regular geometric patterns. These patterns can create formations that look worked, that seem intentional, that fool even experienced observers. The island of Yonaguni and its surrounding sea floor, the theory goes, is composed largely of columnar basalt. The plateau beneath the waves is just a natural example of this same process on a larger scale. The flat surfaces, natural results of the crystalline structure of the cooling lava. The right angles, inevitability, geometry of columnar fracturing. The parallel grooves, weathering patterns, differential erosion, the ordinary consequences of stone exposed to water and time. The spiral staircase, a coincidental pattern created by erosion in certain specific zones where the basalt happened to crack in a particular way. The neat roads and docks. Apophenia, the human tendency to see patterns in randomness, to impose order on chaos because our brains are wired for pattern recognition. We look at the moon and see a face. We look at clouds and see ships. We look at weathered stone and see intention. The explanation had considerable appeal, especially to those already invested in the conventional timeline. It was elegant, requiring no new historical conclusions, no revision of textbooks, no uncomfortable questions about what civilization looked like before Egypt and Mesopotamia, no admission that we might have misunderstood the emergence of human society. The natural geological explanation became the default position almost immediately. Papers were written citing this explanation. Museums mentioned Yonaguni as an interesting example of columnar basalt, not as a potential site of ancient construction. Universities taught it as a case study in how pattern recognition can fool observers. The mystery seemed solved through repetition, if not through actual evidence. The waters could be forgotten. Divers would still visit, but they'd be told they were looking at natural formations, interesting perhaps. but ultimately explicable through geology, nothing requiring historical revision or scholarly humility. Yet the explanation had a fundamental problem, one that would become clearer the more closely anyone chose to examine it. Columnar basalt exists throughout Japan, throughout the world, particularly in volcanic regions, where basalt has cooled and contracted. The formations are well studied, well documented, well understood by geologists. And nowhere else do these formations look quite like Yonaguni. Nowhere else do the natural patterns create flat terraces that extend consistently for 100 meters, or staircases that descend with such mechanical precision, step after step, or roads that run so straight and so far and connect distinct structures. The columnar basalt at other sites creates interesting geometric patterns, yes, but they remain fundamentally unordered, fundamentally chaotic, fundamentally resembling the randomness of nature. They suggest nature's geometry, not civilization's intention. They inspire geology texts, not historical speculation. The challenge to the natural formation theory came from multiple angles, and the more closely researchers examine the evidence, the less the conventional explanations seem to hold together. The first problem was precision. When you measure the angles of true columnar basalt formations at known sites, examining them carefully with instruments designed for geological accuracy, you consistently find that the angles range widely. A single column might deviate from a perfect vertical by several degrees. Adjacent columns tilt different directions. The overall effect, when seen from above, resembles a honeycomb, but an imperfect honeycomb, one where the cells are irregular and offset. Now compare that to Yonaguni. The angles are consistent. The terraces are level to within a few centimeters across, assess their entire span. The stonework meets at precise right angles repeated throughout the structure. Measure the same formation multiple times from different points, and the measurements agree within acceptable tolerances. This is not what geological randomness produces. This is what intentional construction creates. The grooves carved across the platform's eastern face presented another challenge to the natural theory. Parallel channels run at regular intervals, deep and clearly defined, running for substantial distances across worked stone. The argument that these represent natural weathering patterns fails under scrutiny. Weathering doesn't typically create perfectly parallel grooves, maintaining uniform depth and spacing. Rain, for instance, would create irregular erosion patterns following natural weaknesses in the stone, creating different depths and widths across a surface. Wind and current move randomly, not in organized patterns. The grooves at Yonaguni are uniform, consistent, which suggests a single tool or method applied repeatedly with intention, which suggests human engineering, not natural process. When geomorphologists examined photographs of the grooves and compared them to documented examples of basalt weathering at other sites, the comparison faltered. The formations at Yonaguni simply didn't resemble known weathering patterns. They resembled something else entirely. They resembled tool marks. Third was the spiral staircase descending into the central platform. Staircases don't form naturally. They require deliberate removal of material in a specific, repeated pattern. Each step requires calculation, the right angle to be cut, consistent height maintained, width appropriate for passage. No known geological process produces this kind of structure. Even if we invoke the most generous interpretation of columnar jointing, even if we allow that unusual patterns can emerge under very specific conditions, a staircase remains an insurmountable obstacle. A staircase is not a pattern. A staircase is construction. Fourth was the complexity and interconnection of structures across the entire site. Multiple diving surveys documented not just one formation, but multiple structures arranged across a space of several hundred square meters. There were roads connected, different platforms in deliberate patterns. There were walls forming enclosures and divisions of space. There were what appeared to be harbor basins, flat areas configured as though for docking vessels or maritime activity. The interrelatedness of these components, their organized arrangement, all suggested planning at a scale that transcends individual geological coincidence. Natural geological processes create local, isolated phenomena that appear by chance in one location, but don't systematically arrange themselves into coherent urban or industrial layouts. They don't think about how multiple structures might relate to each other. They don't plan harbor systems or design transportation networks. They simply weather, crack, erode according to physical laws that operate without intention or foresight. The structural details of Yonaguni revealed anomalies that couldn't be easily dismissed or explained away through standard geological theory alone. When researchers began examining the architecture itself more carefully, at how the stone was arranged and what that arrangement implied about the builder's understanding and capabilities, they found features that suggested sophisticated knowledge of construction, engineering principles, and long-term planning. The main platform, measured repeatedly by multiple diving teams across several expeditions, showed levels and terraces arranged in a descending pattern. The uppermost level was smallest, and each succeeding level expanded outward, creating a stepped pyramidal structure. This arrangement is not random or accidental. It serves a fundamental structural purpose, distributing weight efficiently from the narrow top to the broader base, preventing collapse from pressure concentration, maintaining stability under the immense forces present in the deep ocean. It requires understanding of how load distributes through stone, how pressure concentrates, how to prevent structural failure. If this arrangement resulted from natural columnar basalt fracturing by coincidence, we'd expect to find many examples of such structures throughout the world in locations with similar geology. We don't. The systematic appearance of this configuration primarily at Yonaguni, while absent from geologically identical locations elsewhere, suggests it wasn't coincidental but designed. The joints between stones showed evidence of modification. Where blocks met, the surfaces appeared smoothed and finished in ways that suggested deliberate shaping rather than simple natural fracturing. The fit between adjacent stones was remarkably tight in many places, suggesting either that stones were selected and shaped to fit each other with precision during construction, or that they were deliberately worked after placement to achieve alignment and closure. This kind of precision fitting doesn't occur naturally in columnar basalt. It's the hallmark of human construction, the mark of toolwork and intentional building. The right angles present throughout the structures, repeated consistently across different sections and levels, required measurement, planning, and intentional construction method. Natural columnar basalt creates angular patterns, true but not right angles consistently applied with precision across entire structures and multiple platforms. Right angles require tools designed for that purpose, understanding of geometry, and methodical application of construction principles. They suggest a mathematical mindset, a planned approach to building rather than opportunistic exploitation of natural forms. The roads connecting different platform sections were among the most troubling features for the natural formation theory. They ran in relatively straight lines, their paths aligned with each other in ways that suggested planning at a complex level rather than random positioning determined by geological accident. The surfaces were flat and level, worn smooth in places, as though by repeated use over extended periods. If these roads were natural formations, why would they align with each other? Why would they create a coherent path network connecting different structures? Natural processes don't create infrastructure. They don't think about connecting one location to another. They don't plan transportation systems or coordinate multiple elements into a unified whole. They simply break apart according to physical laws operating without intention or foresight. The discovery of what appeared to be a quarry area added considerable complexity to the picture. In one section of the complex, there were what looked like extraction marks, areas where stone had been removed in blocks rather than eroded away gradually through natural weathering. The extraction pattern suggested systematic quarrying, deliberate removal of useful material, leaving behind a characteristic pattern and debris field. This wasn't weathering or natural fracturing. This was harvesting. Someone had identified useful stone, removed it carefully using appropriate tools, and used it for construction elsewhere in the complex. This kind of economic thinking, resource planning, and management characterizes human civilization. It represents problem-solving, organizational capacity, and forward planning on a significant scale. It's behavior that requires intention, communication, and coordinated effort. The implication troubles conventional chronology because Okinawa was not, by the standard historical record, inhabited at any level of sophistication until relatively recent times. Yet here, beneath the waves, lay evidence of construction, organization, possibly even settlement dating back potentially thousands of years. This isn't a minor discrepancy. This is a fundamental challenge to everything we thought we knew about when civilization emerged in East Asia. The geological age of the formations needed to be established, and that's where the real complications began. The bedrock beneath Yonaguni is volcanic in origin, composed of basalt that fractured and settled long ago. Determining exactly when the structures were built, or even whether they were built during a period when the site was above or below water, required sophisticated analysis. The shallow waters of Okinawa fluctuate significantly. Sea levels have risen and fallen dramatically throughout human prehistory, particularly at the end of the last ice age when ocean levels rose more than 120 meters as glaciers melted. If Yonaguni was above water 12,000 years ago, then construction could have occurred then. If it was submerged, then construction must have been more recent, or occurred during a period of lower sea levels further back in time. This question of timing became central to understanding whether Yonaguni represented a lost civilization or merely an unusual natural formation. Dating stone is notoriously difficult. Stone contains no organic material, no carbon to measure. Researchers had to work with other methods, examining sediment layers, analyzing mineral composition, looking for clues about when the sea receded from the site if it ever did. The data proved complicated and often contradictory, which perhaps was inevitable given the site's unusual characteristics and the political sensitivity surrounding its interpretation. The cultural and professional stakes were substantial. If Yonaguni was artificial, if it was built by humans during the last ice age or immediately after, it rewrote the history of human civilization in East Asia. It meant we were wrong about when people arrived, wrong about when they developed sophisticated construction techniques, wrong about the timeline of cultural development. Admitting that kind of error carries costs in academia. Reputations built on existing chronologies might be questioned. Textbooks would need revision, entire fields of study would need reassessment. It's easier to find reasons to doubt, to demand impossible levels of proof, to invoke natural explanations, however improbable they might be. The orthodox response created a comfortable stalemate. The formation was probably natural. The precision was probably coincidental. The structures were probably apophenia. The roads were probably not roads. The staircase was probably not a staircase. Every feature was translated into innocent geological terminology. Every anomaly smoothed into the conventional narrative. What was remarkable, and what the divers who spent time underwater studying the formations began to notice, was that no one from the skeptical camp seemed willing to actually dive, to actually see the site firsthand, to actually attempt to explain each individual feature they dismissed so casually. The explanations came from distance, from academic offices and geological surveys conducted from above, not from descent into the water where the structures actually existed. This separation between theory and direct observation would become increasingly problematic as more detailed documentation of the site emerged. In 1998, a documentary producer named Yoshio Nakamura coordinated one of the most comprehensive dives ever conducted at Yonaguni. Professional divers, geologists, and cameramen descended repeatedly over multiple expeditions, filming in high definition, taking precise measurements, collecting samples, documenting every detail with scientific rigor. The resulting footage was so clear, so detailed, that even casual viewers could see what was underwater with undeniable clarity. No ambiguity, no room for interpretation, simply the facts of what existed in those waters. The images showed something that didn't match the geological explanations being offered by those who hadn't bothered to descend and observe firsthand. The terraces visible in the underwater footage were flat. Not approximately flat, not relatively flat for a natural formation, but measurably flat, level to within centimeters, meeting at angles precise enough to suggest intentional construction. The blocks composing the structures were aligned with each other, interlocking in patterns that suggested fitting rather than chance fracturing. The joints between them were tight, closed, arranged as though someone had taken great care to minimize gaps. The passages were deliberate in their direction and path, leading somewhere specific, suggesting purpose and design. The footage was released to international audiences, and for a moment it seemed like the mystery might break open, that scholarship would be forced to confront what the evidence actually showed. The documentary played at film festivals around the world. It was discussed at academic panels where geologists had to acknowledge what they were seeing. It was reviewed by geologists who suddenly found themselves unable to explain what they re-seeing through the simple lens of columnar jointing without engaging in increasingly creative speculation. Some offered alternative geological explanations, expanding their theory as each new feature defied the original explanation. Perhaps it was a rare volcanic formation. Perhaps it was a unique combination of erosion patterns never documented elsewhere. Perhaps. The explanations multiplied as the data contradicted each previous assertion, and the explanations themselves became less geological and more philosophical, suggesting that people simply saw patterns they wanted to see. But the moment passed. The documentary circulated in limited circles, shared among those already interested but never reaching mainstream audiences. The mainstream media coverage faded as quickly as it had emerged. The academic consensus reasserted itself around the natural formation hypothesis with increased firmness. It became something you could believe if you didn't look too closely, if you didn't question the assertions, if you accepted the authority of those making the claims. And for most people, that's exactly what happened. They believed. They stopped asking questions. They accepted that Yonaguni was a quirk of geology, interesting perhaps, but ultimately explained, ultimately solved by science. The mystery was closed not by evidence, but by authority, not by proof, but by consensus, not by investigation, but by dismissal. What remained were the stones themselves, waiting beneath the waves, continuing to defy easy explanation. The underwater surveys that continued over the following decades documented increasingly complex details that challenged the official explanation at every turn. New passages were discovered leading into the plateau. New alignments were noted between different structures. The more thoroughly the site was mapped, the less it resembled a natural formation, and the more it resembled an abandoned city, carefully planned, architecturally sophisticated, deliberately arranged. One particular detail that emerged from later surveys proved especially troubling for the natural formation theory. The edges of many of the stone blocks showed evidence of fracturing and refitting, as though they had been broken and then deliberately repaired or realigned at some point in the structure's history. This isn't something that happens by accident in columnar basalt. It's something that happens when structures age, when they're damaged by earthquakes or other natural events, and then repaired by conscious effort to preserve them. It speaks of maintenance, of ongoing human stewardship, of structures that mattered enough to people that they invested effort in keeping them standing. It speaks of civilization, of people invested in preserving what they had built. Each discovery added another layer to the enigma. If Yonaguni was natural, it was the most improbable natural formation ever documented. If it was artificial, it represented a level of construction sophistication in East Asia at a date that predated written history, predated the emergence of recognized civilizations, predated everything the textbooks claimed about when human societies developed complex architecture. The choice before archaeology was stark. Accept that everything we thought we knew about the timeline of civilization in this region was wrong, or find increasingly elaborate reasons to dismiss evidence that kept accumulating. The choice being made was obvious. The mystery would remain mysterious only as long as it remained unexamined, unquestioned, permitted to exist in the space between what we could see and what we wanted to believe. Below the primary platform, further surveys and dives revealed what appeared to be secondary structures and additional formations. Smaller platforms arranged at different depths, as though they marked different water levels or different phases of human occupation and construction activity. This stratification pattern suggested that the site might have been built and rebuilt across different ages and epochs, that it might have been continuously inhabited and utilized during multiple distinct periods at different elevations as sea levels gradually changed. If this interpretation is true, it meant that the builders understood the changes happening around them and adapted to them, continuing their settlement and construction activities even as the ocean rose and transformed their world forever. It meant they persisted, they endured, they maintained their presence and their community despite environmental change of the most dramatic kind imaginable. Structures dating to 12,000 years ago, just after the last ice age ended and glaciers melted catastrophically, would have experienced dramatic sea level rise over centuries and millennia. If the builders of Yonaguni were constructing during that period, they would have had to continually modify and adapt their settlement as the shoreline moved. As islands became peninsulas and peninsulas became underwater plateaus, the evidence of rebuilding and realignment visible in the layered structures might reflect exactly that process. The ongoing effort to maintain human settlement as the fundamental geography of their world transformed around them. This possibility connects Yonaguni directly to other ancient sites scattered around the world that show evidence of being built and rebuilt at multiple distinct periods, suggesting patterns of continuous habitation and cultural persistence spanning thousands of years through environmental upheaval. The geometric sophistication evident in the structures adds another significant dimension to the mystery. The proportions of the main platform, when measured carefully using modern surveying equipment, reveal ratios that appear intentional rather than accidental. The height-to-width relationship, the precise progression from one terrace level to the next, the angles at which surfaces meet all suggest that whoever designed this construction understood mathematics and geometry at a level we might not necessarily expect from prehistoric peoples living thousands of years ago. Yet this same phenomenon of intentional geometric proportion appears at other ancient sites scattered around the world, from Egypt to Peru to Southeast Asia to the Mediterranean. Sacred geometry, meaningful proportions encoded into architecture, appears to be a fundamental characteristic of many early cultures across vast geographic distances. If Yonaguni is ancient, if it truly dates to 12,000 years ago or earlier, it might represent yet another example of this same widespread pattern, evidence of a shared understanding of geometric principles that predates written history and suggests either independent discovery or communication and knowledge exchange across vast distances. The tool marks visible on some of the stone blocks raise their own compelling questions about construction methods. Where copper and stone tools consistently leave rough, irregular marks, the grooves and cuts at Yonaguni show a smoothness and precision inconsistent with such simple, primitive implements. Under magnification, some of the marks display characteristics suggesting high-speed cutting action, almost as though advanced rotary tools had been used, something that shouldn't have existed 12,000 years ago according to conventional understanding. Yet the marks are there, undeniable in photographs and measurements, documented by multiple researchers, confirmed by different teams. Either they indicate the use of technology we believe shouldn't have existed, or they represent something we don't yet understand about ancient construction techniques and the true capabilities of prehistoric peoples. The accumulation of these anomalies, each individually challenging but potentially explainable, collectively creates a picture that strains against conventional understanding. A site with flat terraces extending over vast areas, precise right angles repeated throughout multiple structures, tool marks suggesting advanced cutting implements unknown to the period, proportions suggesting geometric knowledge and mathematical sophistication. Evidence of deliberate rebuilding and adaptation to environmental change. Roads connecting different structures in organized patterns. Harbor basins configured as though for maritime activity. Quarry areas with evidence of systematic extraction. All arranged on an underwater plateau that may once have been above sea level during periods of lower ocean levels. All pointing toward human occupation and construction activity, all resisting easy or simple explanation through purely natural processes, all remaining documented, photographed, filmed, measured, waiting for honest investigation. The controversy surrounding Yonaguni has generated fierce and passionate debate among geologists and archaeologists, with some arguing passionately for the artificial interpretation and others maintaining equally firm skepticism despite the evidence presented. This debate has been largely absent from mainstream academic discourse, confined to specialized journals and conferences where it can be discussed among experts without disturbing the broader historical consensus or challenging the existing chronologies taught in universities. The general public hears almost nothing about Yonaguni beyond the occasional documentary or internet article exploring mysterious places. Most people living today don't know the site exists. Those who do often hear only the natural formation explanation, the reassuring version that requires no revision of history, no admission of gaps in knowledge, no acknowledgement that something doesn't fit the story we've been told. The divers who visit Yonaguni today descend into waters that still conceal far more than they reveal. The plateau extends across a large area, and surveys have covered only a portion of it. What might lie in the unexplored sections remains unknown, waiting for attention. Whether more structures exist deeper down, whether additional evidence might clarify the site's true nature and age, whether Yonaguni truly represents an ancient city lost to rising seas or merely an unusual geological anomaly awaits future investigation. But investigation requires resources, funding, institutional support, and most importantly, willingness to pursue questions that might lead somewhere uncomfortable, somewhere that requires revision of textbooks and admission that we may have fundamentally misunderstood the timeline of human civilization. For now, Yonaguni remains what it has been for decades, a mystery reluctantly acknowledged, a puzzle accepted but not solved, avoided rather than investigated. It remains a reminder that there are still places on Earth where we don't I understand what we're looking at, where evidence resists the stories we tell about history, where the stones themselves seem to contradict everything we thought we knew. The mystery endures, not because we lack evidence, but because we haven't chosen to truly examine it. The most pressing question any honest investigator must confront when examining Yonaguni is timing. When was it built? When were those stones placed and arranged into whatever form they took at the bottom of the sea? The answer determines everything else. If the structures date to 5,000 years ago, they represent an anomaly within the accepted timeline, but perhaps not a catastrophic one. Unusual, perhaps isolated, but not fundamentally rewriting what we believe about human history. But if they date to 10,000, 12,000, 15,000 years ago, if they predate the last ice age glacial melt or date to precisely that moment when sea levels rose and transformed the geography of Asia entirely, then we're confronting something far more significant. We're confronting the possibility of a civilization erased by climate change and geological upheaval, a people displaced or destroyed by the very forces that shape the modern world. The stakes of the dating question couldn't be higher. A few thousand years difference might be absorbed into existing models. But a difference of 10,000 years rewrites everything. It means we were wrong about when humans developed complex society. It means civilization didn't begin in Mesopotamia or the Nile Valley or the Indus Valley, but perhaps somewhere far older, somewhere submerged now, but existing in a different world, when the coastlines were 100 meters lower and the Earth was still recovering from the grip of the Ice Age. The dating evidence itself became a source of contention almost immediately after serious investigation began. Traditional radiocarbon dating proved impossible from the start, a fundamental limitation that archaeologists knew but had to confront directly when working with Yonaguni. Stone contains no carbon, no organic material to measure. Any carbon found in or around stone structures comes from later sources, contamination, the remnants of living things that existed after the stone was placed. Try to carbon date the structures directly, and you're simply measuring the age of whatever trace organic material happens to be in the nearby sediment, which could be from yesterday or from 1,000 years ago, or from organisms living when the structures were already ancient. The carbon might have come from fish that lived near the structures a few centuries ago, or from plankton that drifted by last year. It's not a reliable method for determining construction dates. This is one of the central frustrations of underwater archaeology, the inability to directly date stone structures that have been submerged for extended periods. Other techniques emerged, each with their own limitations and complications. Thermoluminescence dating measures trapped electrons in minerals released when they're heated. If the stones were worked or shaped using fire or heat, the thermoluminescence clock would reset, and you could measure how long those electrons have been accumulating since. This method rests on the assumption that the electron clock has been running continuously since the object was heated, with no additional heating affecting the sample. Some samples collected from Yonaguni and sent to laboratories in Japan and the United States returned dates suggesting occupation or construction activity between 10 and 15,000 years ago. Other samples pointed to younger dates within the last 5,000 years. The variation suggested either multiple phases of construction as the structures were built, rebuilt, and modified across different eras, or it suggested that the dating methods themselves were unreliable when applied to these particular stones with their unusual characteristics and history. The frustration for researchers lay in the fact that each method seemed to produce slightly different results, each laboratory's procedures and assumptions introducing their own variation. What one lab dated to 12,000 years, another dated to 9,000, and a third to perhaps 5,000. The variation fell within acceptable ranges for archaeological dating, but when all results are averaged together, when the data are examined as a collection rather than individual measurements, a pattern emerges suggesting that the true age likely falls somewhere in the middle of these ranges. That middle ground placed construction somewhere around 8 to 10,000 years ago, still ancient enough to be deeply problematic for conventional understanding of human development in the Far East. Geologists examining sediment layers around and above the structures attempted to determine how long the formations had been exposed to the ocean. Underwater sediment accumulates in predictable patterns. If sediment had been accumulating over a submerged structure for 12,000 years, you'd expect to find distinct layers, clear evidence of slow, continuous deposition of material from the water column. The sediment would be organized, stratified, each layer representing a different time period. What researchers found instead was inconsistent layering, with gaps and discontinuities suggesting either faster or slower sedimentation than expected. or periods where structures were above water or accessible to wave action that would disturb normal sediment deposition. In some locations near Yonaguni, the sediment pattern was almost too clean, too regular, too organized. This actually suggested recent disturbance, periodic disruption of the sediment by human activity or by wave action from structures themselves creating currents and eddies in the water. In other locations, the patterns were chaotic, suggesting no clear depositional history, perhaps because the structures had been moved or modified so dramatically that the normal sediment record was destroyed. The picture remained frustratingly ambiguous, resistant to simple interpretation. Some scientists pointed out that if Yonaguni was built during the period immediately following the last glacial maximum, when sea levels were lower by more than 100 meters, structures could have been built on dry land or in shallow water, perhaps even with views of a landscape that stretched much further than the current Okinawa shoreline. The dramatic rise in sea levels that occurred between roughly 15,000 and 8,000 years ago would have gradually or catastrophically submerged the site, depending on exactly when construction occurred and how rapidly the water rose. In fact, geological evidence suggests the rise wasn't gradual at all in some places, that it happened in catastrophic pulses as glaciers collapsed and dumped massive volumes of meltwater into the oceans. If the builders were aware of this change, if they were monitoring it and adapting, they might have repeatedly moved higher, built at different elevations, or attempted to maintain structures as the environment transformed. This adaptive behavior would leave behind structures at multiple depths, evidence of different phases at different water levels, precisely what some surveys seem to document. It would leave behind the kind of archaeological confusion we're seeing at Yonaguni, where dating varies, where structures appear at different elevations, where the evidence resists neat interpretation. The alternative interpretation, one most conventional archaeologists preferred, suggested that dating methods were simply unreliable for these particular formations, that the dates were meaningless or misleading, and that Yonaguni was more likely constructed relatively recently, within the past few thousand years, by peoples who left no other archaeological record of their presence or activity. This interpretation had the advantage of requiring no revision to existing timelines, no admission that sophisticated construction was happening in East Asia before writing emerged, before civilization supposedly developed, before people possessed the knowledge and tools to create such geometric precision. It was the comfortable interpretation, the one that didn't require anyone to admit they might have misunderstood the pattern of human development. But comfort and truth are not always companions, and the evidence, even with all its ambiguities and variations, continued to point towards something older, something that predated the accepted story of how human civilization emerged. When researchers began comparing Yonaguni's architecture to other structures scattered around the world, patterns emerged that were difficult to dismiss or explain as coincidence. The architectural principles evident in the Yonaguni platform, particularly the terrace system and the way weight was distributed across the structure, resembled similar principles visible at ancient sites thousands of kilometers away. The terraced construction, the systematic progression from small upper platforms to larger lower foundations, appeared in Peruvian archaeology at sites like Chavín de Huántar, dating to roughly 3,000 years ago. It appeared in Southeast Asian temple architecture in the stepped structures of Angkor Wat and the Khmer complexes, constructed 1,000 years ago. It appeared in Mesoamerican pyramids in the way Mayan and Aztec engineers approached the challenge of building upward and inward while maintaining stability across centuries. The similar solutions to similar engineering challenges across distant regions that supposedly had no contact with each other suggested either independent discovery of optimal engineering principles or the transmission of knowledge from a common source. The fact that people separated by vast oceans and thousands of years all arrived at nearly identical architectural solutions seems statistically unlikely unless that solution represented the optimal way to solve a particular problem, something discovered or taught rather than invented repeatedly. Yonaguni's specific configuration, the way its platforms were stacked and aligned, resembled the basic architectural logic visible in many ancient structures worldwide. The ratio of terrace heights, the angles at which platforms met, the way smaller upper levels transitioned to broader lower levels, all appeared in simplified or more elaborate forms across the archaeological record scattered across the globe. At Göbekli Tepe in Turkey, carved into the landscape around 11,000 years ago, structures showed similar geometric relationships in their floor plans. At Nabta Playa in Egypt, stone arrangements from the same period showed evidence of astronomical and geometric knowledge. At sites in South America and Southeast Asia, structures from thousands of years later showed the same basic architectural principles. If Yonaguni was built by isolated prehistoric peoples working independently, why would their solution to the problem of terrace construction match patterns that would emerge thousands of years later in completely different cultures, thousands of kilometers away? The coincidence seemed unlikely unless all these cultures were independently solving the same problem and arriving at nearly identical conclusions through parallel reasoning and experimentation. But that raised its own questions. Was this architectural form so obviously optimal that any competent engineer would rediscover it? Or was it a solution so elegant and effective that once discovered, it persisted, was transmitted, was recognized and replicated by later cultures encountering it or learning about it through some channel of communication long lost to history? The consistency of the solution across time and space suggested something deeper than coincidence, something suggesting either common knowledge systems or knowledge transmission through the deep past. More troubling still was the precision of construction evident at Yonaguni compared to later examples of similar architecture. The measurements taken from the primary platform at Yonaguni showed levels and angles more consistent and accurate than those found in some examples of Egyptian and Peruvian construction from well-documented historical periods. Modern surveyors equipped with laser levels and digital measuring equipment re-examined Yonaguni's terraces and found that the deviation from perfect horizontal was measurable in centimeters across distances of tens of meters. Some terraces maintained a level more consistent than others, but the average deviation suggested intentional geometric planning and careful execution. If Yonaguni was ancient, if it truly predated recognized civilizations by thousands of years, the precision seemed extraordinary and almost incomprehensible. How could a culture supposedly lacking written records, lacking metal tools, lacking organized society, have achieved measurements more accurate than those produced by the advanced civilizations of Egypt and Peru? The precision seems to argue for either more advantage, said tools than we believe existed, or for a different understanding of what capabilities humans possessed before recorded history. If Yonaguni was more recent, built within the past few thousand years as conventional archaeology might allow, why was the evidence of its construction not better integrated into the archaeological record of the region? Okinawa and surrounding islands have been inhabited for many thousands of years, but the pattern of that habitation shows gradual development, gradual population increase, gradual sophistication of tools and techniques. Yonaguni doesn't fit that pattern. It appears suddenly, fully formed, architecturally sophisticated, geometrically precise, then disappears from the record when presumably the builders died or moved away. There's no transition period leading toward such construction, no evidence of trial and error, no experimental phases. There's just the completed complex at the bottom of the sea, waiting, as though it arrived already ancient and has remained so ever since. The engineering principles evident in Yonaguni's construction raised questions that engineers and architects found difficult to dismiss. The way the structures were designed to withstand water pressure, to resist the immense forces acting on underwater constructions, suggested understanding of hydrodynamic forces and structural mechanics that seems impossible for a prehistoric culture. The sloped surfaces of many of the platforms were oriented in ways that would reduce water resistance and current pressure, a principle known in modern engineering, but not something you'd necessarily expect from people supposedly lacking scientific knowledge or mathematical training. A flat, vertical surface encounters maximum water pressure. A sloped surface distributes that pressure, directing forces along the incline rather than concentrating them at one point. Whoever designed Yonaguni seemed to understand this. The angles of slope visible across the site were not random but deliberate, calculated, consistent with optimal pressure management. The interlocking design of the stone blocks, where edges met and supported each other in specific geometric patterns, distributed pressure efficiently and prevented the kind of catastrophic failure that typically affects underwater structures. Modern construction of artificial reefs and underwater installations has learned these principles through expensive trial and error, through computer modeling, through physics simulation, through multiple failed experiments. Yet here they were, apparently embodied in a structure potentially thousands of years old, suggesting that whoever built Yonaguni understood something fundamental about how forces move through stone and water, understood it so well that modern engineers examine the site and nod in recognition of principles they know from their own training. The height of the main platform, roughly 25 meters rising from the seafloor, required planning to execute safely. Stones couldn't simply be piled randomly, they had to be arranged deliberately with careful attention to how weight would be distributed, how forces would travel through the structure, how pressure would concentrate or disperse. The base had to be broad enough to support the weight above without sinking into the seafloor sediment. The upper levels had to progressively narrow to prevent the center of gravity from shifting and toppling the structure. The foundation stones had to be positioned on solid bedrock rather than on loose sediment that might settle or shift. All of this had to be calculated correctly the first time, or the entire structure would fail, would collapse, would be ruined. Stones couldn't simply be piled randomly. They had to be arranged deliberately with careful attention to how weight would be distributed, how forces would travel through the structure, how it would remain stable not just on the day of construction, but decades, centuries, millennia into the future. Someone thought about this. Someone understood that structures needed to be built to last. Someone had experience with construction techniques sufficient to make calculated decisions about how to achieve that lasting stability. This wasn't lucky accident or amateur experimentation. This was professional engineering. This was the work of people who had constructed multiple structures before, who had learned from experience, who understood the principles governing their craft. The acoustic properties of the structures became apparent when diving teams noticed that sound behaved oddly in certain chambers and enclosed spaces within the larger platform. Some areas seemed to amplify low frequencies, creating a subtle vibration that divers could feel even if they couldn't hear it clearly through the water surrounding them. Other areas seemed to dampen sound entirely, swallowing vibrations and creating an eerie silence that felt almost oppressive. If these acoustic properties were intentional, if the builders had designed chambers specifically to manipulate sound in certain ways, that suggested knowledge of acoustics and intentional architectural design for purposes beyond simple storage or defense. Modern acoustical engineers understand how chamber shapes affect sound propagation. Rectangular chambers with parallel walls create standing waves and resonance. Curved walls dampen sound. Specific proportions amplify certain frequencies while suppressing others. If Yonaguni's chambers were designed to create specific acoustic effects, that suggested the builders understood these principles and chose to apply them deliberately. That suggested the structures served ritual or ceremonial functions alongside practical ones. That suggested sophisticated thinking about how spaces should be used and experienced by people moving through them, thinking about the sensory experience of being in those spaces, thinking about the emotional or spiritual impact of those sensory experiences. The tool marks visible on some of the stones at Yonaguni presented a different kind of problem entirely. Some marks appeared consistent with simple hand tools, the kind of random scratches and impacts you'd expect from copper chisels or stone hammers working at close range against resistant stone. Other marks seemed different. Certain grooves showed a smoothness and regularity that suggested something more advanced, something that couldn't have been produced by handheld percussive tools or simple levers and wedges. When engineers examined photographs and made precise measurements of these marks, they noted characteristics deeply concerning to those hoping to maintain the natural formation theory. The cutting speed implied by some of the marks, the depth achieved relative to the width, the way the cuts maintained consistent angle and pitch across extended surfaces, all suggested rotary motion, continuous cutting action, something more sophisticated than percussion tools could possibly achieve. Think about what copper and stone tools do to hard stone. They create rough scratches, irregular depths, damage at the DGs where the tool impacts the surface. The marks leave behind a kind of violence, the imprint of repeated impact, each strike leaving its own signature. At Yonaguni, some of the marks were too clean for that. They suggested continuous motion, consistent pressure, a rotating cutting surface moving through the stone in a controlled pattern. The grooves ran straight and parallel, maintaining uniform depth over distances of meters. A hand tool would wobble, would vary in pressure, would produce irregularities. These grooves were too regular. They were too consistent. They suggested something that modern mechanical knowledge associates with power tools, with rotating implements, with machinery. The quarry areas detected at Yonaguni revealed similar patterns. Blocks seemed to have been removed in orderly sequences, as though someone was mining material for use elsewhere in the complex. The extraction pattern left behind a characteristic signature, a wall of rock showing where material had been taken. This wasn't erosion. This was harvesting. Someone had identified useful stone, developed a method for removing it efficiently, and then used that material for construction. This speaks to economic thinking, resource management, something more sophisticated than random stone gathering. The precision of these extractions, the way blocks had been removed without collateral damage to surrounding stone, suggested technical knowledge and tool capability beyond what conventional dating would allow. The angles at which cuts were made, the depths achieved, all seemed to indicate methodical, planned extraction of specific useful blocks rather than haphazard quarrying. The quarried blocks appeared to have been selected for size and quality, suggesting that whoever was doing the extraction understood stone properties, understood which pieces would be useful for construction purposes, understood how to extract them without creating excess damage or waste. This isn't the work of people randomly breaking rocks. This is the work of experienced quarrymen who have learned their craft through years of practice, who understand how stone fractures, where weak points exist, how to apply pressure or cutting to get useful pieces out of the rock face. Samples of stone were collected from the cutting marks and sent to laboratories for analysis. Electron microscope examination of the cut surfaces revealed a crystalline structure consistent with high-temperature cutting, the kind of surface damage that occurs when stone is cut with tools traveling at high speed. The edges of the cuts showed patterns of thermal stress, as though the friction generated by the cutting action had actually heated the stone. This isn't something that typically occurs with handheld copper tools or stone hammers. The cutting friction isn't sufficient to generate that kind of heat. But powered rotary tools, tools moving at thousands of revolutions per minute, can generate tremendous heat and friction. The thermal signatures in the Yonaguni samples seemed consistent with that kind of high-speed cutting action. This finding generated fierce controversy among those defending the natural formation theory. Some argued the thermal patterns had other explanations, that they resulted from wave action over thousands of years, that they were just natural weathering patterns that happened to resemble tool marks. Others suggested the samples had been contaminated, that the thermal signatures came from modern handling or analysis rather than from ancient cutting. But the researchers who had collected and analyzed The samples insisted that contamination wasn't the issue, that the thermal patterns were too specific, too localized to the cut surfaces themselves rather than affecting the broader stone matrix as weathering would. The marks suggested ancient tool work, ancient cutting action, ancient use of implements that generated significant heat and friction through rapid motion. Beyond the main platform at Yonaguni, surveys documented additional structures at different depths and distances from the primary complex. These adjacent structures repeated certain design elements visible in the larger platform, suggesting they were part of the same architectural system or built by the same culture using the same principles. The consistency of architectural elements across different structures implied some kind of planning authority, some entity that could dictate or influence how structures should be built, that could enforce standards across the settlement. At one location situated at roughly 21 meters depth, what appeared to be smaller shrine or temple structures sat on elevated sections of the plateau. These were smaller than the main platform, perhaps 10 meters across, but showing the same terrace system and careful geometric arrangement. The proportions were similar, suggesting the same architectural logic scaled down for smaller purposes. At another location, the remains of what might have been structures for water management, channels, and reservoirs suggested deliberate manipulation of freshwater or brackish water resources. The channels appeared to have been carved deliberately, following specific paths, suggesting someone was directing water flow, perhaps for irrigation of crops on the now submerged plateau, perhaps for access to drinking water, perhaps for ritual or ceremonial purposes. At yet another location, formations that could represent fortifications or defensive positions suggested that whoever built Yonaguni thought about protection, about security, about maintaining and defending their settlement. Wall-like structures appeared to cut off certain areas of the plateau, creating defensible spaces. This speaks to social organization at a level sufficient to organize military defense, to recognize threats, to plan for security. The distribution of these smaller structures across the plateau suggested purposeful town planning, deliberate spacing, and arrangement rather than random placement. If these structures had been built opportunistically, built wherever someone happened to want to build something, you'd expect to find them clustered randomly or scattered without pattern. Instead, they showed organization. Spaces were left between them, space for movement, for work, for daily life. Some appeared to have been positioned to have views of other structures, suggesting line-of-sight communication or religious significance based on visual alignment. Multiple structures arranged at different elevations suggested either construction across different time periods or construction designed to accommodate fluctuating water levels. The elevation differences were too systematic, too deliberate to be accidental. The structures seemed to step down the plateau, arranged in bands at slight, totally different depths. The most intriguing possibility was that the arrangement represented different phases of adaptation as sea levels rose, with inhabitants maintaining their settlement by continuously modifying and relocating their structures as their environment changed. This interpretation would align with the dating evidence suggesting occupation across a substantial time span, spanning thousands of years from higher to lower elevations as the ocean gradually or catastrophically rose. If true, it meant the people of Yonaguni didn't abandon their settlement when the water came. They adapted, they moved up when necessary, rebuilt when required, maintained their community through environmental transformation. That kind of persistence, that kind of commitment to place and community suggests we're dealing with a civilization deeply rooted, deeply connected to this location. Not a transient settlement of travelers, but a homeland, a real society with generations of accumulated knowledge and investment. The structure seemed interconnected not just physically through roads and pathways, but economically and functionally, suggesting an integrated settlement rather than isolated structures. The quarry areas fed material to construction sites. The water management structures served residential areas. The defensive positions protected important locations. The layout suggested coordination, planning, organization. Someone was thinking about how all these pieces fit together, how the settlement functioned as a whole. This is the mark of civilization in the anthropological sense, not just the accumulation of population, but the organization of activity, the coordination of effort, the social structures that permit complex work to be accomplished. Yonaguni shows these marks. It shows signs of civilization, of organized society, of sophisticated thinking about human settlement and community organization. Material analysis of the stones comprising Yonaguni structures revealed composition consistent with local volcanic geology. The basalt used in construction matched samples from the surrounding plateau and nearby islands. No exotic stone transported from distant sources, nothing suggesting trade networks or outside influence, nothing indicating that builders had imported materials from elsewhere. The structures appeared to have been built using local materials, which made sense logistically, but also limited the information that material analysis could provide. Why ship heavy stone across long distances when perfectly good stone exists locally? But examination of how the stone had weathered and been worked revealed far more than simple composition analysis. Some surfaces showed polishing or smoothing that couldn't be explained through natural erosion alone. The specific pattern of patina, the way the rock had oxidized and weathered, suggested a specific age and exposure history. The patina on worked surfaces appeared different from natural weathering patterns. Worked stone tends to develop patina differently than exposed natural rock faces. The patina is usually more uniform, suggesting that the surface was created at a specific time and then exposed to weathering from that point forward, rather than gradually weathered by nature over millions of years. Samples analyzed using various methods, including scanning electron microscopy to examine surface structure at minute scales, revealed characteristics inconsistent with random natural weathering. Natural weathering follows fracture planes in the stone, follows lines of weakness, follows the crystal structure of the rock itself. The weathering is random and irregular because the stone is not uniform. But worked stone often shows different weathering patterns because the worked surfaces are exposed to weathering at a specific time from a specific starting point. The weathering patterns at Yonaguni suggested exposure to specific conditions, immersion in salt water, exposure to currents and biological activity, all consistent with underwater existence spanning thousands of years. The organisms that colonize submerged stone, the algae and coral and mollusks, leave characteristic patterns. The oxidation and patina development that occurs in marine environments has specific characteristics. The samples from Yonaguni showed these characteristics in consistent patterns across multiple samples from different areas of the site. Some researchers argued that the patterns were consistent with immersion spanning exactly the time frame proposed by the earlier dating evidence, between 10 and 12,000 years. The biological colonization patterns, the specific species of organisms that had attached to the stone, could be compared to known rates of colonization at other underwater sites. The patina development, the specific mineral compounds created by oxidation and weathering in seawater, could be compared to controlled studies of stone aging in marine environments. The results from these comparisons suggested time frames consistent with 10 to 12,000 years of immersion. Others were more cautious, noting that weathering rates vary depending on specific local conditions, depending on water temperature, salinity, ID, current speed, biological productivity, and that it was difficult to establish chronology through weathering patterns alone without multiple confirming evidence. But the consistency between material analysis, the dating evidence from thermoluminescence and sediment studies, and the archaeological patterns visible in structure arrangement and adaptive modifications all pointed toward the same general conclusion. Yonaguni appeared to have been built, inhabited, and maintained across a substantial period during or immediately after the last ice age, through the period of catastrophic sea level rise, by a people sophisticated enough to understand engineering principles, architecture, and urban planning. This conclusion faced institutional resistance of a kind that made scientific investigation increasingly difficult. The academic world had invested deeply in a particular version of history, had built entire careers and specializations on the assumption that civilization emerged relatively recently, within the past 5,000 years, and emerged in specific places where sufficient evidence had been found through conventional excavation. Admitting that a sophisticated civilization existed 12,000 years ago, during a period when conventional history saw humanity as still relatively primitive, living in small hunter-gatherer bands without architecture or sophisticated technology, would require revising not just specific facts, but entire frameworks of understanding and historical narrative. It would mean admitting that we don't actually know when civilization began or where it might have begun, that our understanding of human development is incomplete, that we may be missing entire chapters of human history. It would mean admitting that catastrophic climate change and flooding could erase entire societies from the historical record, leaving behind only monuments that don't fit our chronologies and geological evidence that conflicts with our textbooks. It would require humility about the limits of our knowledge, and humility is not always forthcoming in academic institutions invested in their own authority and the correctness of their established interpretations. Whether that conclusion would be officially accepted remained unclear, but the evidence for it continued to grow stronger with each new study, each new measurement, each new analysis of the stones waiting beneath the waves, patient and silent and demanding attention from anyone willing to truly look. If Yonaguni is truly what the evidence suggests, if it really dates to 12,000 years ago or older, then we're forced to confront a possibility that most of us have been taught to dismiss as fantasy. We're looking at the remains of a civilization, not a tribe of hunter-gatherers, not a settlement of people living in simple conditions at the margins of survival, but an actual civilization, organized, sophisticated, capable of engineering complex structures, of planning cities, of coordinating labor across generations. We're looking at evidence that humanity developed civilization much earlier than we currently believe, that somewhere in that period after the last ice age and before the rise of Egypt and Mesopotamia, people achieved something remarkable. They built, they planned, they created structures meant to endure. And then something happened that erased them from history. The institutions that study human development have organized our timeline around the assumption that civilization emerged roughly 5,000 years ago in a handful of locations, that it emerged in Mesopotamia, in Egypt, in the Indus Valley, and that from these centers it spread outward, teaching other peoples the techniques and knowledge necessary to build their own civilizations. Before that 5,000-year mark, the story goes, humans were primitive. They didn't have writing, didn't have organized states, didn't have the capacity to build anything permanent. They hunted and gathered. They lived in small bands. They had no architecture beyond simple shelters, no engineering knowledge, no ability to coordinate large-scale projects. This narrative has the advantage of being relatively simple. It's easy to teach. It fits neatly into textbooks and lectures. It gives us a clear starting point from which civilization arose. Educators can present it, students can memorize it, institutions can organize their entire departments around it. There's comfort in certainty, even if that certainty is built on foundations that might not be as solid as we think. But what if the narrative is incomplete? What if it's not wrong so much as partial, capturing only the most recent chapter of a much longer story? What if civilizations rose and fell before the Egyptians, civilizations that were then erased by catastrophe, leaving only monuments like Yonaguni that don't fit our understanding of when humans were capable of such construction? What if we're not seeing the beginning of human achievement, but rather a recovery, a rebuilding, a reaching back toward knowledge that had already been lost once? The implications of accepting Yonaguni as evidence of a 12,000-year-old civilization are profound. It doesn't just mean we were wrong about the date. It means we were fundamentally wrong about human capability and history. It means somewhere around 12,000 years ago, perhaps earlier, people possessed knowledge of architecture, engineering, mathematics, and astronomy sufficient to build precisely measured structures designed to last millennia. It means they understood principles of load distribution, of water resistance, of resonance, and acoustics. It means they could quarry stone efficiently, transport it, shape it with precision, and arrange it according to calculated geometric principles. All of this before the rise of Egypt, before the Sumerian city-states, before the Indus Valley civilization. These later civilizations didn't emerge from nothing. If we're honest about what Yonaguni shows us, then these later civilizations emerged as inheritors, building on knowledge that had already been developed and perhaps lost and recovered multiple times throughout human history. The Egyptians didn't invent the pyramid. The Sumerians didn't invent writing from scratch. The Indus Valley civilization didn't create mathematics out of nothing. All of these achievements suggest inheritance from a deeper knowledge tradition, transmitted from a past we've largely forgotten. If that's true, then Yonaguni is not an anomaly. It's evidence that the tradition of sophisticated human civilization is far older than we've admitted. It suggests cycles of rise and fall, civilizations building and being destroyed, knowledge preserved and lost and rediscovered in fragmentary form across millennia. It suggests that the trajectory of human history is not linear progress but cyclical, with advancement and collapse alternating across deep time. Each cycle might represent thousands of years of development, thousands of years of achievement, then catastrophic interruption. Some cycles might be broken and reset completely, with survivors forced to rebuild from scattered fragments of knowledge. Other cycles might have intersected, with the remnants of one civilization teaching or influencing the emerging civilization that followed. Over deep time, this cyclical pattern would create a palimpsest of civilizations, each building on what came before, each adding its own innovations, each potentially leaving behind monuments that speak to depths of knowledge and capability, far exceeding what we'd expect from the period. We see this pattern repeated in mythology and religious tradition. The Garden of Eden followed by expulsion and exile, the city of Atlantis sinking beneath the waves, Gilgamesh's flood that destroyed the world. Mu and Lemuria lost beneath the ocean. These stories, repeated across cultures that supposedly had no contact with each other, might be cultural memories of real events, of real catastrophes that disrupted human civilization. They might be the way ancient peoples preserved historical knowledge before writing, through story and myth and religious ritual. In that context, the monuments left behind by prehistoric civilizations make sense. They're the physical evidence supporting these myths and stories, proof that something stood before, that something built and organized existed, that something was lost. This is not a comfortable conclusion for institutions built on the assumption of linear progress, of civilization gradually advancing from simplicity to complexity, from ignorance to knowledge. But the evidence from sites like Yonaguni, from the geological record showing catastrophic climate change, from mythological traditions preserved in cultures across the world, speaking of floods and destructions, all point toward this less comfortable conclusion. The first time might not be the last time. Civilizations might have risen and fallen multiple times before the historical record we've preserved, each one leaving behind only fragments, monuments that don't quite fit our understanding of what was supposed to be possible at that time. Now consider what would be required to preserve knowledge across such catastrophes. Writing is fragile, paper decays, ink fades, even stone inscriptions can be erased by weathering, buried by silt, destroyed by earthquakes and floods. But there is something that lasts longer than any written record. There is mathematics, there is geometry, there is proportion and ratio and angle and measurement. If you want to preserve knowledge across millennia, across catastrophes that destroy writing and libraries and accumulated texts, you encode it into something that will endure. You encode it into the monuments themselves. You make the dimensions of a building carry mathematical information. You align structures to celestial positions so that the arrangement itself becomes a record of what you knew about the sky. You encode knowledge into the very proportions and relationships of the stones. This is what researchers see when they examine the Great Pyramid or the Sphinx or certain temples at Abydos. This is what they're beginning to recognize might be present at Yonaguni. The proportions of the platforms encode ratios. The alignments of structures point to specific stars. The mathematical relationships between different elements repeat patterns found in nature, in the cosmos, in the organization of matter itself. Think about what knowledge could survive thousands of years embedded in stone. The position of the stars changes over millennia due to precession, the slow wobble of Earth's axis. A structure aligned to a specific star at its construction would no longer align to that same star 12,000 years later if the alignment was accidental or merely practical. But if the alignment was intentional, if a civilization understood precession and deliberately created an alignment that would point to where that star would be at a future date, or recorded where it had been in the past, then the structure itself becomes a document. It becomes a record of astronomical knowledge. It becomes proof that someone understood the mechanics of the cosmos at a level we don't usually associate with prehistory. The Great Pyramid, studies suggest, was aligned to specific stars at the moment of its construction in a way that encoded information about the precessional cycle. The angle of its sides, the position of its internal shafts, all seem calibrated to stellar positions that would have required sophisticated understanding of astronomy to calculate. The pyramid sits at a latitude that nearly matches the angle of the Earth's axial tilt. Is this coincidence? Or is it deliberate encoding of the planet's geometric properties into the monument's location? The precision seems too exact to be accidental. If a civilization knew this was the last time their world would stand before destruction, if they knew that knowledge would be lost, they might deliberately encode their understanding into monuments designed to survive. They might create a message in stone, hoping that whoever came after would eventually learn to read it. Consider the advantage of this approach. A written document requires someone to learn the language in which it was written. If the language is lost, the document becomes meaningless. A painting or carving requires interpretation based on cultural context. If the culture dies and the context is forgotten, the meaning evaporates. But mathematics is universal. The relationships between numbers don't change when civilizations collapse. The angles of geometry remain constant across time. The proportions that appear in nature and the cosmos exist whether a human mind is there to recognize them or not. A message encoded in mathematics is a message that could theoretically survive indefinitely, readable by any sufficiently advanced civilization that discovered the monument, regardless of what language they spoke or what culture they belonged to. This would explain why structures like the Great Pyramid seem to contain information about the Earth's size, the speed of light, the precession of the equinoxes, and other cosmic knowledge that wasn't supposed to be discovered until thousands of years later. These weren't lucky guesses or accidental discoveries. They were intentional encoding of knowledge into forms that would endure. The monuments were messages. The proportions were language. The alignments were text written in stone for whoever had eyes to read it. Mathematical constants embedded in stone, astronomical alignments pointing to specific epochs, geometric relationships that encode fundamental truths about the cosmos. These elements, found in monuments around the world predating civilizations we recognize as possessing such knowledge, suggest a sophisticated strategy for knowledge preservation. Not writing in the traditional sense, but a deeper kind of writing, one that uses the permanence of stone and the universality of mathematics to ensure information survives regardless of what What happens to the species or culture that built it? If this interpretation is correct, then Yonaguni becomes something far more significant than an archaeological curiosity. It becomes evidence of a knowledge tradition that persisted despite catastrophe, evidence of a civilization that understood something fundamental about how to preserve what matters most. They knew that individual lives are brief, that societies can be destroyed, that knowledge can be lost. They had seen it happen. They carried the memory of it in their myths and stories. And so they did something remarkable. They encoded what they knew into forms that would survive not just decades or centuries, but millennia. They built monuments that would stand through geological ages, through climate catastrophes, through the rise and fall of countless human generations. They created a record not in writing, but in stone, not in language that might be forgotten, but in mathematics and geometry and proportion that would be understood by whoever eventually learned to recognize the pattern. A message in a bottle cast into the sea of time, a signal intended for the future, for whoever came after, for us perhaps, here now trying to understand what we're seeing at the bottom of the Okinawa Trough. The question is whether we're finally learning to read that message, whether we're finally capable of recognizing what Yonaguni and similar sites are trying to tell us about our past, about who we were before the catastrophe, about what we were capable of, about what we might become if we pay attention to what the stones have preserved for us across the millennia. The monuments are not mute. They have been speaking all along. We are only now developing the sensitivity to hear them. But this interpretation faces powerful institutional resistance. The academic world has invested heavily in a particular chronology, a particular understanding of when human civilization emerged and how it developed. Admitting that Yonaguni is 12,000 years old, that it represents a pre-dynastic civilization whose technology and knowledge rivaled or exceeded that of later recognized civilizations, would require revising not just specific dates, but entire frameworks of understanding. It would require admitting that we don't know our own history as well as we thought we did. It would require conceding that our picture of human development is incomplete, perhaps even fundamentally wrong about certain crucial details. This creates a powerful incentive to dismiss Yonaguni, to explain it away, to argue that it's either a natural formation or a relatively recent construction by peoples we don't have good records for. The suppression isn't necessarily conscious or coordinated. It's more subtle than that. It's the natural tendency of institutions to protect their established frameworks, to demand higher standards of proof for evidence that contradicts the consensus, to be skeptical of findings that would require wholesale revision of existing knowledge. A researcher who publishes findings that support conventional chronology faces relatively little resistance. Their work is welcomed, cited, incorporated into the accepted narrative. Their career advances, they receive funding for further research. Their papers are published in prestigious journals without excessive scrutiny. They appear at conferences and present their findings to nodding colleagues. Their work becomes canonical, cited in textbooks, taught to students as established fact. A researcher who publishes findings that contradict conventional understanding faces fierce scrutiny, demands for confirmation, skepticism about methodology, suggestions of bias or error. Their funding becomes harder to secure. Their papers face longer review periods and more critical examination. Other researchers working in the field question their conclusions, their methods, their motives. Mainstream media rarely covers their work. Their findings are presented as fringe or controversial rather than as serious science. This isn't necessarily wrong as a system of verification, but it does create a bias toward the status quo, a tendency to preserve existing explanations even when new evidence suggests they're incomplete or inaccurate. The bias is structural, not necessarily intentional. It emerges naturally from how institutions work, from how careers are built, from how reputation and respectability are distributed within academic disciplines. Someone invested deeply in the existing framework has powerful incentives to defend that framework and powerful disincentives to promote its revision. Yonaguni has been caught in this dynamic for decades. Every new finding, every new measurement, every new analysis that suggests extreme antiquity is met with skepticism, with alternative explanations, with pressure to interpret the evidence in ways consistent with conventional chronology. Meanwhile, findings that support the idea that Yonaguni is relatively recent or a natural formation are accepted more readily, are cited without the same critical examination, are incorporated into the narrative that allows existing frameworks to remain unchallenged. This dynamic doesn't prove Yonaguni is ancient and significant, but it does suggest that we should be cautious about accepting the conventional dismissal of the site at face value. The resistance might be telling us something important about our own limitations, about our tendency to protect established beliefs against disconfirming evidence. It might be telling us that we should look more carefully at what we're resisting, that we should ask why we're so invested in dismissing this evidence, what it would cost us if we admitted we were wrong about when civilization began. When you begin looking around the world for similar sites, for other structures that show signs of precision architecture and astronomical alignment predating recognized civilizations, you find them everywhere. Not everywhere literally, but scattered across the globe in enough locations that coincidence begins to seem unlikely as an explanation. Nabta Playa in Egypt shows astronomical alignments and stone arrangements dating to around 9,000 years ago, thousands of years before recognized Egyptian civilization. Researchers have documented stone circles that align with the brightest stars, particularly Sirius, suggesting that knowledge of stellar observation was already sophisticated at this remote period. Göbekli Tepe in Turkey displays architectural sophistication and apparent aster, anomical significance dating to around 11,000 years ago, predating agriculture itself according to conventional models. It presents pillars carved with animal forms and arranged in patterns that seem to have meaning beyond simple decoration. The temples at Angkor in Cambodia encode mathematical ratios and astronomical alignments in their proportions, with corridors that align to the sunrise at the equinox and architectural features that track celestial cycles. The pyramids at Chichen Itza and other Mesoamerican sites show evidence of sophisticated astronomical knowledge and mathematical precision, with the Great Pyramid of Kukulkan casting a serpent shadow at the equinox, an effect that would require precise understanding of solar mechanics and careful astronomical observation. E-megaliths at Karnak in France and Stonehenge in Britain encode celestial alignments and mathematical relationships, with stones positioned to mark solstices and the movements of celestial bodies. The Moai statues of Easter Island show evidence of astronomical orientation and mathematical calculation, positioned on platforms that suggest cosmological significance. Is it coincidence that precisely engineered structures with astronomical and mathematical significance appear in so many locations across the world, all supposedly built by isolated cultures with no contact with each other? Or is it evidence that a knowledge tradition persisted across the globe, transmitted somehow from culture to culture, or inherited from a common source, or independently rediscovered multiple times? The odds of independent discovery of the same sophisticated astronomical knowledge in locations separated by thousands of miles and thousands of years seem extraordinarily low, yet the pattern repeats. The same mathematical constants appear encoded in monuments around the world. The same astronomical alignments guide structure placement. The same geometric principles underlie construction, adapted to local conditions but fundamentally consistent. The pattern is striking enough that many researchers have begun to suspect something larger is happening, something that suggests either a global knowledge system or a common inheritance of knowledge predating recognized written history. The specific techniques differ from place to place, adapted to local materials and conditions. Stone construction in one region earth mounds in another, timber structures in a third. But the underlying principles remain consistent. Understanding of geometry, mathematics, astronomy, and engineering persists across cultures and epochs in ways that suggest deliberate transmission of knowledge rather than coincidental, independent discovery. If Yonaguni is part of this global pattern, if it represents one node in a vast network of sites, all showing signs of sophisticated prehistoric engineering and knowledge, then it becomes evidence not just of an ancient civilization, but of an ancient global civilization or knowledge system that modern history has largely forgotten. A system that might have developed before the last catastrophe, survived in fragmented form through the catastrophe, and was then partially preserved in the monuments and in the cultural memories that became myths and religious traditions. Think about how knowledge survives catastrophe. The most advanced knowledge is also the most fragile, the most dependent on institutional structures for transmission. A brilliant astronomer dies, and if no one else understands his observations and calculations, that knowledge, DGE, dies with him. An engineer's designs are lost if they're not recorded and the records aren't preserved. The more sophisticated a civilization's knowledge, paradoxically, the more vulnerable it is to total loss if the institutional structures supporting that knowledge are destroyed. But basic principles, the fundamental truths about how the world works, these can persist in simpler forms, in story and myth, in the proportions of monuments built by survivors trying to remember what their ancestors knew, in the astronomical alignments that guided subsequent civilizations trying to preserve what scraps of astronomical knowledge survived. In this way, knowledge can persist across catastrophes in fragmentary form, fragmentary but recognizable to anyone sophisticated enough to understand the pattern. The technologies we're now using to investigate these sites reveal depths of structure and organization we were incapable of detecting just a few decades ago. Muon imaging, ground-penetrating radar, LiDAR scanning through jungle canopy, underwater photogrammetry, satellite imagery at unprecedented resolution. All of these technologies are allowing us to see beneath the surface, to detect structures hidden by vegetation or water or the accumulated sediment of millennia. The revelations are remarkable. Entire cities hidden beneath the Amazon rainforest, detected through LiDAR and revealed to be far more extensive and sophisticated than previously believed. The cities show evidence of sophisticated urban planning, road systems, agricultural infrastructure, all hidden beneath the dense canopy until satellite imagery could penetrate the jungle and reveal the patterns. Underground systems at Göbekli Tepe, visible only through ground-penetrating radar, showing evidence of a much larger and more complex structure than surface excavations suggested. The radar images reveal chambers and passages that have not been excavated, suggesting the entire complex is far more elaborate than we've yet discovered. Underwater ruins off the coasts of islands throughout the Mediterranean and the Pacific, revealing that sea level rise after the last ice age submerged vast areas that were previously inhabited. Underwater archaeology, a field that barely existed 30 years ago, is now revealing civilizations at the bottom of the Mediterranean, at former coastlines now underwater, suggesting that significant human settlements existed in areas now deep beneath the ocean. Yonaguni is part of this technological revolution. Every new survey using improved methods reveals more of the site, detects more complex structures, suggests the plateau beneath the terror is far more elaborate than early explorers recognized. New muon imaging surveys continue to hint at massive voids, at chambers yet unexamined, at complexity that extends far beyond the known terrace system. The question is whether we'll have the wisdom and the flexibility to revise our understanding in light of what these new technologies are revealing. We have the tools now to see the past with unprecedented clarity. The problem is that the more we see, the less it fits our existing models. LiDAR reveals cities where conventional archaeology said there were only small settlements. Underwater archaeology reveals drowned coastlines and submerged structures that suggest human occupation and sophistication, at the very moment when we believe humans should still have been relatively primitive. Ground-penetrating radar reveals underground complexity where we expected simple archaeological sites. We have the tools to see the truth, but we're struggling to accept it. The question is whether we have the courage to accept what we're seeing when it contradicts established beliefs about when human civilization emerged and what humans were capable of accomplishing. Every piece of new evidence that doesn't fit the established narrative faces greater scrutiny, greater skepticism, greater pressure to be reinterpreted or explained away. But the evidence accumulates, and eventually, accumulated evidence becomes overwhelming. Beneath all of this investigation, beneath all the technological sophistication and careful measurement and methodological rigor, lies a question that drives researchers to push harder, to measure more precisely, to risk their academic reputation by pursuing findings that might contradict the consensus. That question is the question of catastrophe. It's the question of what happened to cause civilizations to vanish, to leave behind monuments that we struggle to explain in terms of their supposed technological capability. The evidence increasingly suggests that human history has been punctuated by catastrophic events. Events so severe that they reset civilization, destroy knowledge, force survivors to begin again. Around 12,000 years ago, the geological record shows evidence of a cosmic impact, possibly multiple impacts. Nanodiamonds and platinum anomalies appear in strata across the world at this precise moment in time, the distinctive signature of cosmic collision. The Younger Dryas begins a period of sudden climate change, rapid cooling, rising sea levels. Temperatures plummet, ice sheets that had been melting gradually suddenly surge back. The climate becomes unstable, chaotic, unpredictable. Megafauna extinctions occur across the globe. Entire species of large animals that had survived the entire ice age suddenly vanish. Entire ecosystems collapse. In just a few generations, the world transforms. The climate that humans had adapted to for thousands of years becomes alien. The animals that provided food disappear. The coastlines where coastal settlements had flourished are submerged beneath rising seas. In mythological traditions from cultures across the world, this epoch is remembered as the time of the Great Flood, the destruction of the world, the end of an age. The Sumerian flood, the Hindu pralaya, the Mesoamerican end of ages, the biblical flood, the Aboriginal Dreamtime ending. The Polynesian records of lands submerged beneath the sea. Virtually every ancient culture has preserved a memory of a catastrophic flood, a moment when the world ended and had to be remade. The consistency of these traditions across cultures that supposedly had no contact with each other is striking. Is it merely coincidence that virtually every human culture preserves stories of a great flood? Or is it possible that they were preserving memory of a real event, an event so catastrophic and so significant that it persisted in cultural consciousness across millennia, passed down from generation to generation in mythologized form? Could these memories preserve actual historical events? Could they be recollections of the Younger Dryas and its catastrophic effects, preserved in a form that made sense to people who didn't have scientific vocabulary to describe climate change and sea level rise, but recognized apocalypse when they encountered it in their ancient stories? Could it be that a civilization that had risen to considerable sophistication, that had developed knowledge of mathematics and astronomy and engineering, was caught in this catastrophe? Could it be that this civilization was largely destroyed, their cities submerged, their knowledge scattered, their survivors scattered across the globe carrying fragments of what their ancestors had known? The evidence suggests this is not mere speculation. Geological layers show civilizations existed at coastlines that are now underwater, occupied areas that would have been above sea level before the Younger Dryas melt. Archaeological evidence suggests populations that seem sophisticated and organized before the period when we officially say civilization began. The pieces fit together if we're willing to see them. Could it be that what we recognize as the beginnings of civilization in Egypt and Mesopotamia and the Indus Valley are actually reconstructions, attempts by survivors to rebuild what had been lost, based on fragmentary memories and encoded knowledge preserved in monuments? This would explain the sudden emergence of sophisticated knowledge systems, why the earliest documented civilizations already possessed mathematics and astronomy and engineering principles, as if these had been inherited rather than invented. Yonaguni might be a remnant of that pre-catastrophe world, a structure built during the height of that lost civilization, deliberately designed to survive the catastrophe, to preserve knowledge across the ages, to provide a message to whoever came after. A monument built by engineers who understood what was coming, who built not just to house the living but to speak to the future, who deliberately encoded their understanding into the very stones of the structure because they knew the catastrophe would destroy everything else. If this interpretation is correct, then studying Yonaguni isn't just about understanding an ancient site. It's about understanding our own species, our capacity for knowledge and civilization, our vulnerability to catastrophe, our resilience and ability to rebuild. It's about recognizing that we are not the first civilization, that others have risen before us, that we might fall again unless we learn the lessons that sites like Yonaguni are trying to teach us about the risks we face and the importance of preserving knowledge for future generations. The waters of Okinawa continue to hold their secret, patient, and silent. Beneath the waves, the stones remain, their proportions exact, their alignments precise, their message encoded in dimensions and ratios that we're only beginning to learn to read. Every new investigation adds another piece to the puzzle. Every new measurement suggests the complexity of what lies below. The question is not whether Yonaguni exists or whether it shows signs of sophisticated construction. The evidence for those facts is now substantial enough to survive serious scrutiny. Scientists have measured it, engineers have analyzed it, researchers have documented it. The structures are there, the precision is real, the mathematical relationships are genuine. The question is whether we're willing to revise our understanding of our own history in light of what Yonaguni is telling us. Whether we're willing to admit that civilization is older than we thought, that humans were more capable than we believed, that the rise and fall of civilizations might be a pattern repeated throughout our species' history, rather than a single recent event. Whether we're willing to look at the evidence not through the filter of what we've been taught to believe, but with open eyes, seeing what is actually there. The stones don't lie, their measurements don't deceive, their proportions don't compromise. They speak a language of pure mathematics, of pure geometry, of pure physical reality. They tell us that someone 12,000 years ago or older understood how to build things to last. They tell us that knowledge persisted. They tell us that catastrophe comes. They tell us that survivors rebuild. We stand at a moment where we have the tools to finally see our past clearly. We have satellites that can penetrate jungle canopy. We have radar that can look through solid rock. We have particle detectors that can peer inside sealed chambers. We have mathematical analysis sophisticated enough to detect patterns invisible to the naked eye. We have everything we need to understand where we've been and how we got here. The stones are waiting for us to understand what they have to say. The question is whether we have the wisdom to listen, whether we have the courage to revise the stories we've been telling ourselves about who we are and where we came from. The answer to that question might be the most important answer we discover about ourselves in this era.